Hello everyone. So today we're going to talk about addition law of probability. But before that, let's discuss first the term mutually exclusive events. So two events are mutually exclusive when they cannot happen at the same time. So we can think of it using Venn diagram as disjoint sets. Okay. So when two sets don't have the same elements, okay, then they are disjoint. So, if we're going to relate it with mutually exclusive events, so if the outcomes in event A and the outcomes in event B cannot happen at the same time, then they are mutually exclusive. So, they don't have the same elements. Okay? But if the two events can happen at the same time, so there are common outcomes in both event A and event B, then we can draw their Venn diagram as overlapping or intersecting sets. Okay? So as you will look in event A and B, there is a common area between the two. Okay? And this is the intersection. Okay, denoted by A and B. Okay, so these type of events are not mutually exclusive. Okay, let me show you an example on how to identify events that are mutually exclusive and not mutually exclusive. So suppose we have event A as randomly selecting a jack from a standard deck of 52 playing cards. Event B, randomly select a face card from a standard deck of 52 cards. So in event A, the outcomes are Jack of Hearts, Jack of Diamonds, Jack of Clubs, and Jack of Spades. In event B, Queen of Hearts, Queen of Diamonds, King of Hearts, and so on. Okay, so all the face cards in total. Okay, now looking at the outcomes in event A. So the outcomes in event A, okay, can be found in event B. Okay, so there is a common element. We can actually illustrate it in a Venn diagram. So if we will draw a Venn diagram, let's say this is event B. Okay, this big circle is event B. Since all the outcomes in event A are also in event B, then the elements in event A are inside B, right? Okay, so we can say that A is a subset of B. Okay, since event A and event B can happen at the same time, so they are not mutually exclusive events. Okay, next problem. So event A, randomly selecting a vehicle that is a Ford. Event B, randomly selecting a vehicle that is a Toyota. So Ford and Toyota are different brands of vehicles, okay? And it is impossible for us to have a vehicle that is a Ford and a Toyota at the same time, okay? So if we will draw a Venn diagram for these two events, okay? So if this is event A, randomly selecting a vehicle that is a Ford, and then this will be event B, okay? So they don't overlap. Okay, they cannot happen at the same time. So the two events are mutually exclusive. Okay. So identifying if the two events are mutually exclusive or not mutually exclusive events will be helpful in using the formula for addition law of probability. So the addition law of probability states that if the probability of A or B will occur, then it is given by the formula probability of A or B equals to the probability of A plus the probability of B minus the probability of A and B. Okay, so this is our general formula. In symbol, okay, we use the symbol union for or, intersection for and. Okay, now we can actually simplify this formula. Okay, but the purpose of subtracting the intersection of A and B is to avoid having double counting. Okay, especially with the elements between A and B. Okay, that are common to each other. Okay, but if the two sets are disjoint. Okay, so imagine if the two sets are disjoint, then there will be no common elements. Then the probability of A intersect with B will be 0. Okay? And if that is 0, then what will remain is only this part. Okay? So this formula will be used when the two events are mutually exclusive. Okay? Since the probability of A intersection of B is 0, so the formula can be simplified into probability of A plus probability of B. Okay, I repeat, if the two events are mutually exclusive, then you will use this formula. But if the two events are not mutually exclusive, you will use the general formula. Okay, let me show you an example. So you select a card from a standard deck of 52 playing cards. Find the probability that the card is a 4 or an ace. Okay. Look at the diagram. Okay. Do we have common elements between the two sets? Okay. Or between the two events? Okay. No, we don't have. Okay. So we can say that the events are mutually exclusive. So if they are mutually exclusive, from the formula, we can simplify this by just adding the probability of getting a 4 plus the probability of getting an ace. So the probability of 4 or ace is given by the probability of 4 plus the probability of getting an ace. Since we have 4 fours in a standard deck of 52 playing cards, the probability of getting a 4 is 4 over 52. And then we have 4 aces in a standard deck of 52 playing cards. So the probability of getting an ace is also 4 over 52. So adding them together gives you 8 over 52. And then we can simplify the fraction. So 8 over 52 is 2 over 13. So the probability of getting a 4 or getting an ace is 2 over 13. Okay. Let's have another example. So the table shows the results of a survey that asked 2,850 people whether they were involved in any type of charity work. A person is selected at random from the sample. Find the probability of each event. Okay, so this is our table. So you have the data for male and female, and then the type of charity, okay, the involvement in charity, frequently involved, occasionally involved, not involved, okay, and then the total. Now we're going to answer the following question. Find the probability that the person is frequently or occasionally involved in charity work. Okay, so let's identify event A first. So event A is um, the person is frequently involved. Okay, so frequently involved. in charity work. Okay? While event B is occasionally involved. Okay? So looking at the table, okay, frequently and occasionally don't have common elements. Okay? So we can say that the two events are mutually exclusive. So since they are mutually exclusive events, we can use the simplified formula. Probability of A or B is equals to probability of A plus the probability of B. So the probability that a person is frequently involved in charity work is 428 over 2,850. And the probability that the person is occasionally involved is 886 over 2,850. So adding the two fractions will give you 1,314 over 2,850. In simplest form, so 1,314 divided by 2,850. So this is 0.461. Okay. So the probability that the person is frequently or occasionally involved in charity work is 0.461. Okay. Let's continue. So find the probability that the person is female or not involved in charity work at all. Okay, so this is our data for person not involved in charity work, and this is our data for female. Okay, so they have a common element. Okay, so we can say that it is possible that a female, okay, is not involved in charity work. Okay, then we can say that the two events are not mutually exclusive. Okay, so A, the person is female, then B, the person is not involved in charity. Since the two events can happen at the same time, therefore, the two events are not mutually exclusive. Okay. So from here, we have the formula probability of A or B for not mutually exclusive events is probability of A plus probability of B minus probability of A and B. Okay. So probability that it is a female is 1,378 all over 2,850 plus the probability that a person is not involved in charity work is 1,536 over 2,850 minus the probability that the person is female and not involved in charity work is 741 over 2,850. Okay, so using calculator, so we have 2,171 over 2,850. So converting it to decimal, that gives you 0.7617. Okay? So the probability that the person is female or not involved in charity work at all is 0.7617. Okay, let's have our next question. Find the probability that the person is male or frequently involved in charity work. Okay, so event A, the person is male. Event B, the person is frequently involved in charity work. Okay, okay. So let's look at our table. So it is a male, okay, frequently involved. So it is possible for you to have a person that is a male or frequently involved in charity work at the same time. Okay? So since the two events can happen at the same time, then they are not mutually exclusive events. Okay. So using the formula for not mutually exclusive event, so that is probability of A or B, I will use the union equals to probability of A plus probability of B minus the probability of A intersection with B. Okay, so the probability that a person is male is given by 1472 divided by 2850 plus. Okay, the probability that um, it is that the person is frequently involved in charity work is 428 over 2850 minus the probability that a person is a male and frequently involved in charity work is 221 all over 2850. Okay? So 1472 over 2850 plus 428 over 2850 minus 221 over 2850 is 1679 over 2850. Okay? Writing it into decimal will give you, okay, so the probability that the person is male or frequently involved in charity work is 0.5891. Right? Okay, so last question. The person is female or not frequently involved in charity work. So there are two events. So event A, the person is female. Event B, the person is not frequently involved in charity work. Okay. So, not frequently involved means the person might be occasionally or not totally involved in charity work. Okay, so event B is the complement of the event which is frequently involved in charity work. Okay, so since it is possible that the person is female and not frequently involved in charity work, then the two events are not mutually exclusive. So we can write the formula probability of A or B is equals to probability of A plus probability of B minus probability of A and B. So probability that it is a female is 1,378 all over 2,850. Probability that the person is not frequently involved, okay, is given by 2,422 all over 2,850 minus the probability that the person is female, okay, and not frequently involved is given by 1,171 over 2,850. So 1,378 plus 2,422 minus 1,171 is 2,629 over 2,850, which is in decimal 0.9224. Okay, so the probability that the person is female or not frequently involved in charity work is 0.9224. Okay, so that's how you use addition law of probability. So it is important that you know how to differentiate mutually exclusive events and not mutually exclusive events. So if the two events can happen at the same time, then the events are not mutually exclusive events. But if the events can happen at the same time, then they are mutually exclusive events. Okay? So that's it for today. I will see you next class. Okay, goodbye.